So let's talk about the flows that you have in a positive estuary. So essentially, a positive estuary has three connections or three openings, shown here in this sketch. Okay, so there's the connection to the rivers, okay, which is called R here. And through this connection, there is a certain volume transport of fresh water delivered to your estuary. Volume transport is a cubic meters per second of fresh water is delivered. And you can work this out from two things. First of all, you need to know the cross-sectional area. Okay, so what's the cross-sectional area? Depth and width gives you cross-sectional area. And you know what's the average speed of the flow. And if you multiply the speed with the cross-sectional area, you get the volume transport. And you can do that here at the river entrance, and you can work out what your R value. You also have two connections to the ambient ocean. One is the outflow in the surface layer, and the other one is called Q1, and the other one is the inflow through the bottom layer, Q2. And you can also work out these flows, and what you need to do is you have to average over a tidal cycle. That makes sense, doesn't it? Otherwise your estimates are biased. So you average over a tidal cycle, and you can work out what Q1 is, you can work out what Q2 is, you can work out what R is. So now a fundamental property is conservation of volume, because the water you can't compress. So all that comes into your estuary has to also move out. Okay, so what comes in is R and also Q2. So you have two sources of volume coming in, and this has to be balanced by the volume flowing out, which is Q1. This automatically implies that the outflow, volume of outflow, has to exceed the inflow of river water. And this is what we call flow magnification, because the Q1 can be significantly bigger than the R. And this is what happens in highly stratified estuaries. So now, how is the flow magnification factor defined? You essentially go to the mouth of your estuary and you work out two speeds. One is the average speed averaged over a tidal cycle of the outflow. We call it US. And the other one is the average of the vertical, the depth average speed. Okay, the depth average speed. Okay, averaged over a tidal cycle at the estuary mouth. So this is what scientists have used. Okay? And then if you do that, you come to a different flow regimes. And I show you on the next slide. Not yet. Okay? So let me just have a little break, and then we continue here, okay?